Take a plunge into the deep blue depths of any of the world's oceans today, and you would be lucky to encounter a reptile. Out in the open waters, your best bet would be to catch a glimpse of a sea turtle, perhaps a hawksbill, or a giant leatherback. Closer to shore, sea snakes and occasionally lizards and crocodilians venture out into the waters. But in the 21st century, a truly marine reptile is a rare occurrence. In the Mesozoic era, the time when dinosaurs had the run of the land, the oceans were, in fact, teeming with marine reptiles, unlike anything else that exists today. Popular media is filled with depictions of these reptiles, from long-necked plesiosaurs to the fish-like ichthyosaurs. These creatures take their place proudly next to the pterosaurs as some of the most famed organisms of times gone by. The truth is, these reptiles were not only commonplace in the seas of the Mesozoic, but were extremely diverse. Turtles and crocodilians existed, just as they do in the modern day, but some of them would be near unrecognizable to an uninformed time traveler. The plesiosaurs in particular were one of the most diverse groups of Mesozoic marine reptiles, ranging hugely in size and form, from the long-necked titans we're familiar with to short-necked varieties, who during the latter half of the Mesozoic took the throne next to the mighty mosasaurs as the apex predators of the turbulent, unforgiving waves. All of this can be said without even touching on the oddities of the Triassic period's waters, a time when weird reptiles were present in every cove, bay, sea, and coastline in the world's waters. Here, groups of reptiles utterly unfamiliar to modern zoology thrived in huge numbers, blossoming into a seemingly infinite range of forms and niches. Today, we will be taking a tour through time, a whistle-stop journey through the oceans of our prehistoric world, where we will meet some of the major groups of marine reptiles that thrived from the start of the Triassic period to the end of the Cretaceous, right up to the cataclysmic KPG extinction event. Hold your breath. It's going to be a dangerous dive indeed. The Triassic period's sheer diversity of marine reptile groups forces us to have to fit everything in one fleeting chapter of this video. If we were to go in depth on each and every group present throughout the dawn of the dinosaurs, we would be here all day. Following the terrible volcanic events of the end Permian extinction, the single worst mass extinction in the history of planet Earth, plenty of marine ecological niches were available to those adaptable enough to take them. This resulted in the reptiles taking center stage, above the arthropods, temnospondylus, and cartilaginous and lobed-fin fishes of the Paleozoic era, diversifying into forms previously unknown to natural history. The first of these strange lineages we'll explore are the placodonts. Appearing in the fossil record towards the Middle Triassic, these were bulky, slow-moving, sometimes shelled creatures, superficially similar to turtles, that were highly adapted molluscivores, with specialized crushing teeth to crack the tough shells of bivalves and other shellfish. The most famous of the group is Placodus, a 3-meter-long reptile that lived much like a walrus or manatee. Its teeth protruded out past the mouth in a circular curve and were perfectly adapted to this derived lifestyle. Through the use of heavy bones and voluminous lungs, Placoderus could keep itself submerged with little effort as it sifted through the sand of its coastal home environment. Placodonts were a diverse group in themselves, however, and throughout the late Triassic, creatures such as Hanodus were beginning to evolve. Turtle-like in appearance, yet totally unrelated, several authors have likened the lifestyle of this strange reptile, with a broad, flat shell and crushing beak, to that of rays or cephalopods. It would have spent much of its time on the sea floor, sweeping its spoon-shaped mouth back and forth through the sandy sediment, crushing shellfish carapaces as it went. High above the Placodonts, towards the surface waters, swam the Nothosaurs. These potentially ancient relatives of the plesiosaurs were almost similar in appearance. They boasted long necks and tails. Some of them had evolved proto-flippers, and they subsisted on diets of fish as they gracefully whirled and wheeled through the surf. Nothosaurus is the most famous of the group, a widespread and successful reptile with fossil remains known from Western Europe to Eastern Asia. The long skull, equipped with needle-sharp interlocking teeth, would have created an effective fish trap, allowing this speedy reptile to snap up its prey with relative ease. Likely semi-aquatic, the Nothosaurs are theorized to have bred on the shorelines in colonies, taking to the seas to feed, much like a seal or sea lion would today. Throughout the course of the Triassic, relatives of the Nothosaurs took on more and more plesiosaur-like traits, with creatures such as Pistosaurus, with its long neck and 4 flippers, taking on a pretty much stereotypical plesiosaur appearance. The Thalattosaurs were perhaps some of the strangest of the Triassic marine reptiles. With paddle-like limbs and long, tapering snouts tipping their slender frames, these reptiles were mostly Nothosaur-like fish hunters, with the exception of some genuses. Zinpusaurus, in particular, was a true oddity. It possessed a long, needle-like snout, with which it would have probed the sea floor for fish and shellfish hiding beneath the sand, before snapping it up further back along the skull with needle-sharp teeth. The true oddities could be found elsewhere, however. Tanystropheus has become a semi-popular creature associated with early Mesozoic seas. The long-necked shore reptile, who used its colossal, sweeping neck as a fishing rod to snap up fish from the surf. Recent studies, however, have shown that Tanystropheus was not adapted to a life at sea. Its cousin, however, Dinocephalosaurus, was. Still boasting the freakishly long neck, so synonymous with that of its cousin, it wasn't large enough to feed in the same way. But its feeding method would have been equally remarkable to watch in life. Approaching shoals of fish, Dinocephalosaurus would thrust its neck forward from a retracted position, launching its open jaws forward towards its target, consuming not only the fish, but the water surrounding them also. This suction effect would have made it an efficient predator, as bizarre as it was graceful. Search weird Triassic reptile on the internet, and it won't be long before you find a picture of a Topodentatus. This strange Sauropterygian has undergone a significant change since its initial 2014 description. First thought to possess a bizarre, upward-oriented zipper-like structure on its upper jaw, it is now theorized that this odd animal wielded a broad, flat, duck-like bill, similar in form to the head of a hammerhead shark. It would have used this mouth, which would have been lined with chisel-like teeth, to sweep left and right along the shore to snap up shellfish and other invertebrates hiding in the sand. This is by no means an exhaustive list, but the Triassic period is known specifically for harboring a whole all-star cast of bizarre marine reptiles. The perfect first stop for this underwater tour through time. A whole host of ichthyosaurs had established themselves in the seas across the world by the end of the Triassic period. In fact, some of these ichthyosaurs were amongst the most spectacular creatures ever to exist, let alone some of the most marvelous in their group. If the Triassic is known for its ichthyosaurs, it is known for Shastasaurus and Shonisaurus. At the time they evolved, they were the biggest creatures ever to exist on planet Earth. At 21 meters long, Shastasaurus, the larger of the two genuses, was only slightly shorter than a blue whale, the biggest animal ever to live. With an appearance falling somewhere between that of a shark, whale, and crocodile, these gigantic marine lizards were pretty much untouchable and would have feared little to nothing in the primitive seas in which they ruled. Subsisting on a diet of fish and squid, pods of these giants would have been a truly majestic sight out in the open Triassic oceans. They weren't alone in the Triassic seas, however, and a whole host of other ichthyosaur genuses were beginning to establish themselves. Some of these include the traditionally fish-shaped ichthyosaurs, such as Mixosaurus, to the decidedly more reptilian, such as Symbospondylus and Bisanosaurus. Cardoryncus, an early basal member of the group, is theorized to have been a semi-aquatic transitional member of the group. A true ichthyosaur, yet one that lived and looked not much like one at all. Throughout the Mesozoic, the ichthyosaurs were an extremely successful group of marine reptiles. The Jurassic period, specifically its fossil formations along the coastlines of the United Kingdom, are particularly known for being ichthyosaur gold mines, and many finely preserved specimens have been unearthed since the time of Mary Anning, an accomplished fossil collector and paleontologist known for her ichthyosaur discoveries in the early half of the 1800s. Many of the Jurassic ichthyosaurs were firmly more fish-like in appearance than the more reptilian-looking animals that preceded them in the Triassic. Ichthyosaurus itself, the namesake of the group, is known from Jurassic rocks in southern England, along with a handful of other iconic genuses, Temnodontosaurus and Ophthalmosaurus, to name a few. These creatures would have looked like fish and lived like dolphins, yet were in no way related to either. With large eyes and powerful bodies, they would have been perfectly adapted to tear through the open oceans after shoals of fish and gatherings of squid, using their long, spear-like jaws to entrap individuals with their needle-like teeth. The ichthyosaur legacy would come to a gradual end as the Jurassic progressed, with just one known, but now seemingly invalid genus making it to the waters of the Cretaceous. Platypterygius, known from Australia, North America, and the UK. This is a wastebasket taxon, a name given to the sparse and unknown remains of the ichthyosaurs that made it to the Cretaceous. By the time the ichthyosaurs had died out, the oceans were anything but void of marine reptiles, however. The Cretaceous oceans would prove to be filled with some of the most iconic creatures ever to swim, as we will shortly discover. Once depicted as sluggish creatures that wallowed in the primordial seas of times long past, akin to plump aquatic sauropods, modern science has proved that the plesiosaurs and their relatives were anything but. The general form of the classic plesiosaurus, with its elongated snake-like neck, short teardrop-shaped body, stubby tail, and 4 paddle-like flippers, is recognizable amongst pretty much anyone and everyone, young or old. Over the years, however, the plesiosaur has taken quite the trip, as have many other prehistoric creatures, to the point where they are essentially new animals. The vintage image of a plesiosaur lifting its long neck out of the water in a swan-like shape is now very much archaic. Studies on the mobility of the vertebrae have shown that the necks of plesiosaurs were relatively inflexible, and that these iconic oceanic reptiles instead held their necks out straight in front, a tool used for infiltrating shoals of fish, like a biological harpoon to snap up prey. Plesiosaurs, over the years, have also fallen victim to shrink wrapping, the process whereby paleoartists recreate extinct animals based solely upon research of the skeleton, omitting vital components such as musculature, fat, adornments, and textures. Plesiosaurs were, in life, much more complex than the initial images make them out to be, with muscular necks, powerful limbs, and streamlined shapes that would have made for fast-moving, agile predators. Generally, 2 forms of plesiosaur are known: the long-necked plesiosaurs and the short-necked plesiosaurs, a commonly referenced clade of which are the pliosaurs. Pretty much all of the known plesiosaurs are either speedy piscivorous hunters or powerful marine apex predators, and the group was successful throughout the Jurassic and Cretaceous periods, adapting to fill a huge number of oceanic niches. The long-necked plesiosaurs made their first concrete claim in the oceans in the early Jurassic period, where creatures such as Attenborosaurus, Macroplata, and Plesiosaurus itself sped through the waves after shoals of fish. Plesiosaurus is now almost a wastebasket taxon, where plesiosauroids of uncertain placement in the fossil record are placed before being assigned to other genuses. Attenborosaurus, named after the legendary naturalist and television presenter Sir David Attenborough, was the classic long-necked plesiosaur. With an incredibly long neck and 4 powerful flippers, it would have ruled the seas around the southern United Kingdom in the early Jurassic. As the Jurassic progressed, so did the evolutionary lines of the long-necked plesiosaurs. Continuing up the United Kingdom's Jurassic coast, we encounter late Jurassic plesiosaurs, such as Morenosaurus and Cryptoclydus. The former, a 6-meter-long bulky animal. The latter, an agile, smaller creature with a shorter neck. Heading into the Cretaceous period, the long-necked plesiosaurs entered their golden age as some of the most widespread and diverse marine predators. Elasmosaurus is surely one of the most famous of all extinct marine reptiles, and many different species of them persisted across the south-central United States in the late Cretaceous. While they hunted close to the surface waters out in the open oceans, other stranger plesiosaurs were staking their claims to the deeper waters in the early Cretaceous. The deep, dark depths of the oceans around western Russia harbored Abyssosaurus, a large-eyed, long-flippered relative to Cryptoclydus of the late Jurassic. Due to the size of its eyes, it is theorized that this creature hunted in the deepest parts of the ocean, able to withstand a great deal of pressure as it snapped up deep-dwelling Cretaceous fishes and squid. As for the short-necked plesiosaurs, the Jurassic would see them embark on a lineage of some of the most awesome and iconic predators of the marine seas. And it, too, started in the waters surrounding the United Kingdom. Romaliosaurus was one of the first pliosauroid plesiosaurs, or short-necked plesiosaurs. With a keen sense of smell, a powerful, streamlined form, and 6 meters of muscle packed into its body, Romaliosaurus was an incredibly powerful predator of the early Jurassic oceans. Its interlocking teeth would have created a perfect fish trap, and its neck, atrophied to shorter proportions, was the first sign of what was eventually to come: a lineage of massive, powerful marine predators. Carrying on through the late Jurassic, we witness the pliosaurs in full swing. Growing to an estimated 6 meters in length, with the potential capacity to grow much larger, this creature was the star of an episode of BBC's iconic dinosaur documentary, Walking with Dinosaurs, where it was incorrectly depicted as a 25-meter-long killer. While it was indeed a large animal, it was much smaller in reality, and was one of the first pliosaurs to show the typical, classic form that would be so prevalent in the pliosaurs of the Cretaceous. It would have lived the life of a reptilian shark, tearing through the waves after its vertebrate prey, ensnaring it in long, toothy jaws. It shared the waves with its smaller relative, Palaeoneustes, a pliosaur specialized for hunting cephalopods. Its inflexible body structure would have been streamlined enough to dart through the waves as it chased, dolphin-like, after prey. The pliosaurs of the Cretaceous continued to diversify even further. Dolichoryncops was even more dolphin-like than its Jurassic predecessors, at 5 meters long, with a slightly longer neck. Its long, narrow jaws would have been perfect for snapping up fish and squid that thrived in huge numbers in the seas of the central United States towards the end of the Cretaceous. By far, the most spectacular pliosaur of all, however, was a creature native to the open oceans of Australia and South America, Kronosaurus. named after Kronos, a Greek mythological titan. This 9-meter-long terror would have had the largest skull of any known marine reptile, consisting of around a third of its entire body length. Living like the macro-predatory toothed whales of the modern day, this creature would have been able to use its powerful body to bring down a whole host of creatures in the waters around it, from fish to squid, all the way along through plesiosaurs and other pliosaurs. Truly, it was one of the most mesmerizing predators of the entire Mesozoic. Viewers of Jurassic World will be very familiar with Mosasaurus, the gigantic marine lizard that breaches out of the water to consume a shark suspended from a feeding pole in a SeaWorld-esque setup. While the creature in the film was oversized and inaccurate, the mosasaurs themselves were no small fry, and some of them made up the largest and most powerful apex predators of the Cretaceous oceans. The mosasaurs were a very widespread group of large, fast-moving marine predators, most closely related to modern snakes and lizards. In fact, their closest living relatives are the monitor lizards, such as the Komodo dragon, with which they share an order, Squamata. Unlike the monitors, who occasionally venture into water to catch prey or to travel territories, the mosasaurs spent their entire lives at sea, replacing legs for flippers and sporting a deep, paddle-like tail to propel themselves through the water. They grew larger than any monitor lizard. The largest of the group grew to a whopping 11 meters in length and would have been a keen predator of large fish, cephalopods, sharks, turtles, plesiosaurs, pliosaurs, and even other mosasaurs. One of the largest and most well-known species was Tylosaurus, native to the western interior seaway that cut through the United States in the late Cretaceous. It was similar in form to the mosasaur depicted in Jurassic World. With its bulky form and powerful tail, it may have slammed into its prey, stunning them before it tucked in. This was evidenced by the damaged snouts found in some Tylosaurus specimens, indicating that many individuals would have led violent lives. Some mosasaurs, such as the slightly smaller Platycarpus, were capable of crushing the shells of ammonites, tossing and turning the shell over in its mouth to deconstruct the unfortunate invertebrate's defenses before tearing into the soft body within. Platycarpus is also the most commonly unearthed mosasaur, which famously possesses a series of tooth-like structures facing towards the back of the throat to help force prey down the gullet and into the digestive system. Prognathodon, a late Cretaceous mosasaur known to deposits in Europe, North America, and Oceania, seems to have lived much like the Triassic placodonts, sifting through the sand for hidden shelled creatures, crushing its meal with broad, conical teeth. New Zealand's Tanyosaurus, on the other hand, appears to have been a keen chaser of fish, evidenced by its powerful tail and long, narrow jaws, which, combined with its relatively small size of 6 meters, would have been useful adaptations to help it dart through the waves like a swordfish or mako shark. We may know mosasaurs as the terrifying, bulky tyrannosauruses of the sea, as depicted in popular media, but they certainly weren't all like that. In life, they were no doubt as beautiful and diverse as the other marine reptiles which called these ancient seas home. As we have explored in previous videos, crocodilians weren't always the slow-moving ambush predators they are today. In times gone by, crocodilians and their extinct relatives were some of the most diverse creatures, with multiple varying genuses represented in single locations. Armored crocodiles lived out on the deserts and plains. Galloping crocodiles hunted in scrubland and grassland. Arboreal crocodiles mastered the trees, and marine crocodiles were present in the oceans. Metriorhynchus is one such genus of crocodilians, native to the Jurassic marine deposits of what is now France. Like many crocodilians today, it owned long, narrow jaws used for snapping at fish and other vertebrates, 4 limbs, and a long tail. The main difference in Metriorhynchus, however, was its ownership of flipper-like structures on the limbs, and a shark-like tail fin in place of a scaly paddle. These features plainly indicate the presence of a crocodilomorph that spent its life at sea, out in the open oceans inhabited by the plesiosaurs and ichthyosaurs of the Jurassic. It would have indeed coexisted with some of the creatures aforementioned in this video, and it wouldn't have been uncommon to spot some of its relatives elsewhere too. Although many species of marine crocodilomorph are well known from across the seas of the Jurassic and early Cretaceous, 2 species aside from Metriorhynchus are well known. These are the Geosaurus and Dacosaurus. The former, a 3-meter-long fish hunter, similar in form to many modern crocodilians. The latter, a 5-meter-long predator with a much bulkier form. No Dacosaurus eggs or nests have yet been found, leading to scientists being generally stumped as to whether this creature gave live birth, like a dolphin, or came ashore to lay eggs on the beaches, like a turtle. Just as they are today, turtles were one of the most diverse and successful reptile groups throughout the Mesozoic. Today, there are 7 species of sea turtle, who make up one of the only group of truly marine extant reptiles. These range in size drastically, from the small Kemp's Ridley turtle to the gigantic leatherback sea turtle, and many species are now threatened with extinction. Throughout the Mesozoic, some turtles got truly gargantuan, surpassing even the mighty leatherback in size. Archelon is the most famous of these turtles, a species of ocean-going giant that reached over 4 meters in length from nose to tail. It still possessed the shell so synonymous with living turtles, which would have proved an efficient defense against the predatory sharks and mosasaurs it shared its home with. Other species were present too, however. The oceans of the Cretaceous saw a slew of other large prehistoric turtles, which included the 3-meter Protostega, a much more lightweight form with a reduced shell. Its beak was broad and heavy, which would have allowed it to crush the tough carapaces of its invertebrate prey. Allopleron is another example of prehistoric sea turtles growing to large sizes. At over 2 meters long, this genus, native to Europe, Asia, and North America, show the adaptations of a generalist. It is theorized that the very diet of this turtle combined jellyfish, seaweed, and even carrion. Interestingly, only adults have been found, leading scientists to believe that the young lived elsewhere, perhaps spending their lives in shallower, safer water before heading out to the open oceans as adults. Today, many of the marine reptiles that aren't turtles are snakes. Sea snakes inhabit coastal waters and coral reefs, often highly venomous, and move through the water, undulating their bodies from left to right, making them easily mistakable for eels. Sea snakes were also prevalent in the seas throughout the Cretaceous, relatives of the mosasaurs that had gone down a very different evolutionary path. Many snake fossils have been found in marine limestone deposits, but strangely enough, it would appear that some of these snakes still possess the remnants of their hind limbs, reminiscent of the lives they led on land in millennia gone by. All snakes in the modern day have atrophied these legs entirely, to the point where they all move independently of the use of limbs. Sea snakes, throughout the Mesozoic, are not well represented in popular media, but include genuses such as Palestine's Pachyrhachis and Haseophis, Bosnia and Herzegovina's Pachyophis, and Lebanon's Eupodophis. These snakes are known to have been marine vertebrates that inhabited shallow waters in environments heavily associated with fossil fish, leading scientists to believe that many of them were piscivores. Whether or not, like modern sea snakes, they were venomous is yet to be proven. And with that, we conclude our tour through the Mesozoic oceans. Prehistoric marine reptiles are as iconic, in the context of the dinosaurs, as the pterosaurs that soared high above their watery domains, and many are often mistaken for dinosaurs themselves. The marine reptiles were diverse, evolving on a completely different line to the dinosaurs, but did indeed coexist with many different species. Tyrannosaurus itself would have wandered coastlines of seas teeming with mosasaurs, plesiosaurs, and giant turtles, and maybe even interacted with them. Hundreds of amazing species are known, and that number continues to grow. Even very recently, the mighty apex predator Thalassotitan was unearthed. If something the size of a whale can be hidden in the rocks below us, what else is waiting down there to be discovered?